All right, I want to go through the answer key to the day 4 assignment on linear regression in video format. So the first one we have is a convenience store manager notices that sales of soft drinks are higher on hotter days. So he assembles the data in a table. We see that here. Make a scatter plot of the data using the Desmos graphing calculator. So that's where we're going to start. We are going to go ahead and enter in the Desmos.com website. So Desmos.com, click on graphing calculator. And we need to enter our data over here off to the side. So we click the add new item table, and we're going to enter our data. So after we enter our data, the next thing we want to do is view what it looks like over here. So to see what our scatter plot looks like, you can try to move things around or zoom out. What's actually easiest is just click this little button here called Zoom Fit, and it will move the screen for you. So we can see here that the data appears to increase or rise as you move further to the right on the graph. So going back to our assignment, we can tell that based on that trend, that is definitely a positive trend. So I'm just going to go ahead and circle. Correlation is positive. The actual R value from Desmos and the linear equation of the trend line is found when we enter our equation for regression into Desmos. So we have to enter that, the y1 squiggle equation. So we go back in here. We model y equals mx plus b. I change the equal sign to a squiggle. And then because my table has x1, y1 at the top, I'm going to put the little ones after x and y. And I get the information I need. I see my line of fit, my trend line is there. And the actual R value is right here. I can't select it, but 0.9673. Not R squared. I don't want the top number. I want the bottom number there. 0.9673. 9673. All right. Part D, the linear equation. So remember that we always model y equals mx plus b. So I need the slope, which is 16.4163. Don't forget to put x after your slope. And then I would put a plus there, but I don't remember if the y-intercept was positive or negative. It's actually negative. So I'm just going to do minus 621.826. So minus 621.826. I do want to quick just double check that number. Yep. All right, so that's my equation of that trend line. This line right here, this line of best fit, that's the best possible line to match our data. And there's a lot of calculations that go into telling us that's exactly where that line is. So part E, use the equation to predict the soft drink sales if the temperature is 95 degrees. Okay, so in our table, which one was temperature? Well, temperature was on the left side, so that's your X value. So they're basically telling you if X equals 95, what does Y equal? That's what they're asking us. So we have to use our equation to solve. So I have my equation, y equals 16.4163 times x minus 621.826. Notice I didn't round those numbers. I didn't cut any of those off. Never want to round anything until we get to our final answer, and then we'll round to whatever makes the most sense based on the data. So I have to do a little bit of math. I have to type this into my calculator. And I can do that on Desmos. Where we had 16.4163 times 95 degrees minus 621.826. So I don't have a great memory. I just use the numbers from up here. So mx plus b, which in this case is just minus. And I get 937.7225. So we have to think about what makes the most sense there. Our X value was the temperature. The Y value was the number of soft drink cans or soda cans that were sold on that day. So let's see, it would make the most sense to round to the nearest soft drink can without decimals. So the nearest would be 938 soft drinks, because the first digit after the decimal point was a 7, which reminds us to round up. So 938 soft drinks. All right, that's number 1. Let's take a look at number 2. All right, we've got some anthropologists here looking at femur length and height of some partial skeletons. All right, so we need to make a new scatter plot. So I'm going to need to go back into decimals, and I could clear this out, but it's better if I start from scratch. So I hit the 3 bars, I hit new blank graph, and I want to enter in a new table of values. So I go to add table, and my data. Femur length goes on the left, and height goes on the right. All right, things look good. You can see my data if I hit the zoom fit button. I can see a definite positive trend here. It's trending upward again. So let's go to our assignment and mark positive. So A is done, B is done. Part C and D. C is the equation, part D is the actual R value. So to do that, I need my code. All right, I see the R value is 0.9658, 0.9658. 0.9658. My equation is going to model y equals mx plus b. And I just need to copy down my slope. So 1.9231, 1.9231. And I need my y-intercept. We have 80.6809. 80.6809. There we go. Keeping in mind, x is the femur length and height is the, y is the height. So an anthropologist finds a femur length of 58 centimeters. How tall is the person? So they're basically saying, if x is 58, what is the height? In other words, what is y? So we're going to use our equation and a little substitution. Say y equals 1.9231 times my new x value of 58 centimeters plus 80.6809. And I just do a little bit of math. So let's see, 58 centimeters is my x value. I can see here it's y equals 1.9231 x plus 80.6809. And my x value was 58 centimeters. Put it in parentheses so your calculator knows to multiply it. And we end up with 192.2207. Remember that this was actually the height of a person. And if we look at our table, the y values are all rounded to the nearest tenths. So we would be, we would want to mark ours to the nearest tenth as well. So one digit after the decimal. So we're trying to decide, do I keep this 2 or do I bump it up? Well, after that 2 is another 2, so that would mean don't round it up. So 192.2 centimeters would be the height of the person. 192.2 centimeters.